that continuous time unit impulse is related to the continuous time step with some relation. What was that? No, we saw that, yeah, it's a derivative of unit step signal, right? And we saw that it's not an ordinary function. Why? Because any function, see, when we call a function as an ordinary or a continuous function, see, this is abnormal function which is having only one value at one instance and is having nothing, okay, and doesn't have any value otherwise, right? So it's not an ordinary function. Its integral doesn't exist I mean, at least Riemann integral doesn't exist, okay, because that impulse is only existing at t equal to 0. That is unusual, right? This function can't be integrated. That's why we have found some new way to represent that function. We have defined some new way. What was that? With respect to some other function we have defined. That's why we called it as a generalized function. We defined it as, what was that? Del of t, phi of t. We define this del of t as an effect it will do on the phi of t. That's how it is defined. We define it as, it will be del of phi of 0 when, yes please, isn't it? Or it's well defined between this interval. Let's say this is a, this is b, and this is 0. If this interval is between a and b and 0 comes in between that, then only it is phi of 0, otherwise not. So this, huh, what, well, I'll come to that. And it's 0 otherwise. I won't say otherwise, but in this interval, if a and b exist in between this interval and this interval, it is 0, and then you can define that b greater than this a greater than 0, and it is undefined or negative side. Okay, this is positive side. Which one? Oh yeah, this one. You can understand now. This, it should be between, so it should be between, sorry, this b must be greater than 0, right? Is that okay? B is greater than 0 and a is 0 is greater than a. Okay, that's nothing like कोई rocket science नहीं है इसमें, ठीक है? If this a and b is defined exactly, if a and b interval contains 0, then only it is defined at phi of 0. This we are considering a single value just because we are taking an integral or an area under it. Okay, if that is not the case, that means if we are defining del of t, phi of t, then it will be this will be phi of 0 del of t. That's what you were saying, right? When we are taking an area, it would give a scalar. It would give a scalar. When we are taking multiplication of two signals, of course it must give a signal which is actually scaled by this value. Okay, whichever the value exists between at this interval, at that point, at 0th instance. And of course, if this del of t is shifted, then we would have this del of t minus t naught being scaled by the value at t naught. That is what we have seen, right? Later on we have seen that it's equivalent in the discrete time domain, where we don't have such kind of ambiguity there, isn't it? Apart from this, we had a definition which was something like this. Del of t was having an area equals to 1. That's why it was called as a unit impulse. Unit impulse. Later on we have seen what was called as a it's discrete time equivalent. We have seen there was no such ambiguity. It was well defined on 0th instant, at 0th instance, and otherwise, isn't it? What was that? And tell me the definition. Del of n, which was 1 at n equals to 0 and 0 otherwise. What about u of n? It was 1 for n greater than or equal to. You should note that it's not infinite. Okay, but these are very important signals. We have seen its significance. I mean, how they are important. isn't it? It's actually they are used as a practical test signals, isn't it? Now, and it's 0 for n less than 0. That's what we have seen. Later on, we have seen the transformation of independent variables. Which kind of operations we have seen? First, we have seen the time shift. Later, scaling. And we noted that if x of t is actually transformed to x of at, depending on this a value, okay, whether it is greater than 1 or it's less than 1, but of course greater than 0. No, it depends. When a is greater than 1, it is actually compressed. Okay, always remember that. Okay, and if it is it is between 0 to 1, it is expanded, isn't it? I give you as a homework for you to okay. Although I would like to say something, although this course doesn't have any kind of lab, I would highly appreciate if you people do this kind of simulations in MATLAB software. Okay, I've already given MATLAB software to some of you. So what you can do is, this MATLAB software, when it's completely installed, it looks something like this. This MATLAB software, it's math lab, so it's matrix laboratory. That means everything in this can be viewed as a matrix or a vector. Say for example, I'm saying something, my voice is coming like this. If I read this voice in MATLAB, it would read as some samples, because it's a digital, right? This computer is digital, so it will save some values in digital form. That means this will have some value, this will have some value, and so on. Once you read that signal, okay, so that can be in MATLAB, that can be done using what is called as audio read. I give you as a homework to search for this function audio read, which will help you in reading MP3 or WAV files. So the homework is to read any small duration signal, audio signal. Say for example, tune, your mobile tune, Nokia tune, Microsoft tune, anything, okay, or any MP3 or any song you like. You read that in MATLAB and do such kind of operations. Say time shift. What do you mean by time shift? If I relate it to the audio, yeah. So it's a function which is available. I will show it to you. Now this MATLAB software, okay, wait, I will just show this to you. This MATLAB software, once installed, looks something like this. It has a lot of buttons. You hardly have to deal with all of them. So it's very simple, okay. So after opening, you will see such what is called as a command window, where you can quickly do some operations. Say for example, I would like to do 2 plus 2, so it's 4. That's it. Very simple. You don't need to define integer, hash include stdio.h, hash include conia.h, nothing like that. Simple variables, answer you'll get. Say for example, I'm writing sign of, say 2, I'll get some values. Depends on if it is taking as a radian or if it is taking as a degree, isn't it? For example, I need to plot anything. Plot. What do I need to plot? Say for example, I need to plot values from 1 to 100 or 1 to 10. For example, I will simply write 1 to 10. That's it. It will plot. You don't need to define any matrix or any array in that. Yeah, it will take some time. So it is plotting some values from 1 to 10. You should note that this is not continuous. It's discrete. Although so now it's not getting displayed as a discrete. To make it display as a discrete, I will say it as stem. That's it. It will display as a discrete function 1, 2, 3, 4, and so on. It is plotting the values 1, 2, 3, 4, and so on. So I give you as a homework. Now this audio read is a function in MATLAB. Okay. Say for example, I am writing here this one, audio read. If you find it difficult, it is having some syntax. Okay, I won't spend much time here on the simulation. I will just give you an overview. So this is the function audio read. You just need to give a path of the audio file and it will be completely read in the variable on the left hand side. Say for example, this is the variable v. It will be completely read in this variable. I give you as a homework to find this, to simulate this and do such operations. Say for example, time shift. Now in case of audio, if you take audio context, in context of audio, what would be time shift in audio? Say for example, I'm playing some Nokia tune or any MP3. If I make a time shift of, let's say, 1 second, Now you should first ask where the time shift should be done. Okay, I mean, say for example x of t is the signal which I am having, and I have time shifted it to, let's say for example, t minus 3, where 3 is seconds. So what will happen? The tune will play. Yeah. Yes. So it will be mute for first 3 seconds, and after 3 seconds it would be play. Say for example x of t plus 3. What would happen? It will start after, this is again a challenging job to, to play it. Okay, what you can do is you can simply skip those 3 seconds of samples and you can start playing. But by doing such operation, you should demonstrate how this time shift operation would reflect in the audio. What is the application? YouTube audio player, ये जो भी है आपको forward reverse तो करती हो आप. There it is very useful. If you want to play it at, after some time, you simply delay it. If you want to forward it ahead, okay, you just make it an appropriate time shift there. Okay, good application. So whatever we are learning here, it's not garbage, it will be useful. Now scaling operation, which we have seen, x of t when it is transformed to x of at, it depends how you depending on the value of a, it is expanded or compressed. If a is greater than 1, it will be compressed. If a is between 0 to 1, it will be expanded, right? I give you as a homework to play with this, scaling operation in with any audio. Okay, say for example, what would the effect on audio if I am scaling? Yeah, if it is x of 2t, what will happen to the audio? Yeah, it will be played at faster and slow. You should not say both the things. Okay, it would be played not either. What is 2 here? It will play fast. Of course, it would play fast because, okay, if this is a signal, it will get compressed like this. I mean, if a signal is to be complete, if a song is to be played for 5 minutes, it is getting complete at 2.5 minutes. Okay, what is happening? It is being played fast, right? We are simply skipping alternate samples. So in discrete case, it will be what? X of twice of n. I give you as a homework to, now that is just for your for getting more insights into the operation, okay, of this transforming operations. Go for x of 0.5 n and x of twice n. Do such kind of operations on audio. What if it is 0.5 n? Now this, you have to be very careful. This 0.5, if n is 1, it is x of 0.5. It doesn't exist, by the way. So that means you have to be, you have to do some kind of, this is somewhat challenging. Okay, that's why I've given as a homework to you. So it will be played. What do you expect? We expect it to be played at slower pace. So what should we do? We have limited number of samples. Let's say we have 100 samples. That has to be played very slowly. How much slowly? Twice slowly. I mean, half of its speed if I need to play it. What should I do? I'll simply insert a sample in between that, or I will simply replicate some samples, or I may insert some zeros. That is one way of doing it. If I do that, I'm having more samples to be played, right? So the song which was for the duration of 5 minutes will be played for 10 minutes and so on. Okay, so I give you as a homework to to simulate such things in MATLAB. Read any small file. I'll also demonstrate that in the class. If you are unable to do that, it's very simple. Okay, so yeah, we don't have to do anything with the amplitude here. Right. Okay, the quantization and sampling rate is by default set by this MATLAB. So audio read, it will be setting up standard sampling rate as 44100, as you know, kilohertz. Okay, 44100 hertz. It's a standard sampling rate which you can change otherwise. Okay, assume you can take lower sampling rate and save low number of samples. So just as to get an idea. Yes, of course. Yes, of course it is. You might have heard MP3 song when you download. हमारे ज़माने में मतलब अपना ही ज़माने में थोड़े साल पहले 64 kbps वाले पहले हम डाउनलोड करते थे. बाद में 128 kbps वाला एकदम कड़क क्वालिटी का गाना था. अभी 320 और उसके ऊपर भी है ना. नहीं आते क्या? है कुछ वेबसाइट्स पे, मैं बताऊंगा आपको। मतलब इसका मतलब क्या, एक सेकंड में इतने हजार सैंपल्स, इतने हजार बिट्स हम अलोकेट करते हैं। दैट मींस मोर नंबर ऑफ बिट्स आर बीइंग अलोकेट टू इन 1 second, राइट, टू दैट सॉन्ग। दैट्स व्हाई द क्लैरिटी एंड द क्वालिटी ऑफ द सॉन्ग इज वेरी हाई। आप सुनो कभी 132 kbps वाला गाना सुनो, मजा आएगा। You can only hear Kishore Kumar songs or Mohammed Rafi songs in that, but if you go for Yo-Yo Honey Singh, you have to go for 320 kbps song. Okay, otherwise you won't get the feel of that music. So that's how it is. Um, yes, please. Yes, yes. Right. When we grab it, it's an analog signal. When you are capturing it, it becomes digital signal. Yes. 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 Yes, of course. Okay, we'll come to that very interesting question, Chaitanya. So it's like this. I'm having a song, nice song, which is being played in sinusoid fashion. What do? I can't save infinite number of samples. What do? I simply save only discrete number of samples here and there. Now it depends how do I sample this signal. As as you predicted, there will be some kind of loss in between the samples, as because we are not saving complete samples. So there is what is called as very nice theorem which was posed by Nyquist. What Nyquist said was, if you sample the signal properly, he has given some equation for that, then this complete signal will be, you will be completely able to recover this signal back. Isn't it beautiful? That means, say for example, this signal is having a frequency of, let's say, 2 hertz, maximum frequency of 2 hertz. If you sample it as 4 samples per second, that means twice the sampling rate, minimum sampling rate. Minimum, I'm just bothered about how much minimum samples I should consider. If I'm just able to sample only twice of the, the maximum frequency of the available signal, I will be able to completely recover back the original signal. That was the theorem which was posed by Nyquist and which we are going to see in your subsequent lectures. Right? So that's very interesting question, and we shall see more into it in the subsequent lectures. The timing will come back to that. So yes, of course there will be loss, but that is completely, that can be overcome. Yeah. Right. Yeah. So this is the audio signal which you can read, and you can just don't worry about the processing what is done inside. We'll come to that, step by step as and when required. Okay, we'll go step by step and slowly. Next. After that, we have seen some. Have you seen? Okay, one more operation which I would like to tell is about reflection, or it's called as a reflection, or this, or time reversal. That means when x of t is transformed to x of minus t. That means what? If I'm having the signal starting exactly from 0, now time goes like this, right? From 0 onwards, it process. This is what x of minus. That means I'll simply keep a mirror. I'll simply keep a mirror here, and I'll simply see its reflection. What is it? It's simply be a replica of this. So such kind of operation is called as a time reflection or reversal. Now you should note that there is a difference between this and this. This reflection is not amplitude wise. It is time wise, just because we are doing the transformation of independent variable. Always remember, when x of minus of t is the independent variable, so it should reflect along across this time axis. This should be reflected, not like this. If this is the case, then what would be the, yeah, if it's a minus, now that minus won't be reflected here. It will be what? Yes, it will be minus of x. It's as good as what? Amplitude scaling operation. But right now we are seeing the operations in, yeah, to the independent variable. Right? Similar case, similar case applies to the time scaling operation. Now here we are scaling the time axis, okay, not the amplitude. If you scale the amplitude, the height of this signal will be reduced. Say for example, x of 2. Now there you have to record if the signal is twice of x of t, the amplitude will be what? It will be reduced. Yes, it will be greater. That's not the case here in time. Okay, it's completely reverse. Okay, it's completely opposite. You should be very careful about the transformation of which variable we are dealing with. Okay, is it the dependent variable? If it's a dependent variable, twice will be simply twice the amplitude of the signal, and if it is twice of the independent variable, it will simply compress. Okay, so reverse operation. All right. So yeah, application. Now sometimes now in audio case, if I read an audio file, if I time reverse and play it, it will be played in reverse fashion. It will be very interesting to hear that signal. I mean, it won't be useful. I mean, that's what it वो कुछ तो प्ले होगा. तो ट्राई करके देखो, मैंने ट्राई किया है, आप भी ट्राई करो. टेक अ नोकिया ट्यून and play it in the backward fashion. See how it looks like. Alright, now what would be an application for this? Okay, ठीक है, मतलब रिवर्स तो करते हैं, इसका application क्या हो सकता है? So just yeah, you'll see, this there is something which we'll be using this very frequently, and we'll come to that when we shall be using it. Just be patient that this application will come in subsequent lectures. Okay, just I'm just telling the operation of this, what the reflection would be and how it would manifest itself in the physical domain, but its applications will be seen in the subsequent lectures. Now, all right. Now we have seen all these operations individually. We may have all of them in combined. Say for example, x of t may get transformed to x of at plus b. What kind of operation is happening here? This a, yeah, maybe scaling. No, wait. Yes. So b may be as the shift variable, and a not only scaling. Well, a may be -1, so that may also be reversal. So it may be scaling or reversal. I mean, not this is not equivalent to this, or no. You got what I'm saying? So say for example, x of t get transformed to x of 2t plus 3, or I may write it as x of minus t plus 2, and so on. If you are dealing with such signals, you have to be very careful. Okay, very careful. Say for example, now before writing complete detailed procedure for this, I'll simply throw it as a problem to you. Okay, just for example, you just take this signal. Okay, this is my favorite. So very simple, just because it's very simple, I'm deliberately taking such kind of signal. Example, this is consider this signal. This is 1, 2, and amplitude is 1 here. Let this be x of t, and you need to draw signals x of t plus 1, and all right. Okay, go for this. This operation is very simple. T plus 1. क्या करना है बोलो? Go step by step. We'll go step by step. Let's go step by step. ये कौन सा ऑपरेशन है बोलो? x of t plus 1. बोलो कहाँ शिफ्ट होगा ये पूरा का पूरा सिग्नल? Towards left shift. Why? Why? अब इसका पिछले पिछले लेक्चर में we have spent some significant amount of time on this, right? Why? Yeah, and so on, right? Draw this signal. How does it look like? It simply gets shifted by 1 unit, okay, towards left. So this will be something like this. Is that okay? ये क्या रहेगा? -1 0 amplitude. Oh, sorry. Yes, 1. Yes. This is what? X of t plus 1. Similarly, x of t minus 1. It will be shifted by what? 1 unit towards right. What is this? 1 x of t. Is that okay? Now this is more challenging. You draw it first. Draw it first. How many of you are able to do it? Let's see. With respect to time, आईना यहाँ पे रखो. This is mirror यहाँ पे आईना रखो. और यहाँ पे रिफ्लेक्शन नहीं है, इसके साथ आप शिफ्ट किए. Okay, so as expected, people have done some mistakes. No, it's very good to do mistake because when I'm at your place, I will also do some mistakes. Wait, see here. Observe very carefully. एक्स ऑफ टी है ना, इसको ट्रांसफॉर्म कैसे किया अपन ने, एक्स ऑफ माइनस टी प्लस वन है ना, हाँ माइनस टी प्लस वन, ये कैसे मिला होगा? Say for example, this there is some box to which we have given x of t, and there is another box, no, which is taking the output from the first box and and processing it. Now it depends what is the first operation. Is it shifting or it is flipping? Why? You didn't ask that question. Why? Board mass. Oh my god. Board mass doesn't work here. No, 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 no. So okay, okay. Okay, I'll prove you wrong. Now, what if, for example, I need to get signal? We'll go both ways. We'll go both ways. Okay, let's check both ways. Eh, We'll come to that. We'll come to that. X of t. For example, if I'm taking flip operation first, x of flip operation first, and then if I'm now this, let me write flip plus flip first, and then shifting na, t shift किया ना, x of minus t, अच्छा ठीक है, मतलब यहाँ पे माइनस लिख देता हूं मैं, अब तो सही है, अब तो सही है, ठीक है. Say for example, okay, instead of this I will take the generalized case. यहाँ पे confuse मत हो, I will take a generalized case. I'll take a very generalized case. अभी आपको ध्यान में आएगा आपका mistake क्या. X of what? I'm taking flipping first and then shifting. Let's say I'm shifting by some amount. Let's say t naught minus t. Don't worry about this minus. This t naught may be plus or minus anything. What if I do shifting first? X of t minus t naught, and then while flipping I'm flipping the independent variable x of minus t. Here the flipping operation is done first and shifting next. Here we are doing shifting first and flipping next. Are these two signals same? No, isn't it? We'll take another case, x of, now instead of minus, okay, I will take generalized case of x of at plus b. Okay, so say for example I am scaling it first, x of at, and then I am shifting it, x of t shift कर रहा हूं ना मैं, t minus. Is this a shift operation? Okay, now we'll do the reverse way. First I will shift x of t minus b, and then I will scale x of, क्या scale कर रहा हूं मैं, हाँ, so 80. Are these two the same? Exactly. Now depending on the equation what has been given to you, can you tell me what operation has been done first? Huh? You observe it very carefully. Observe it very carefully. You observe it again very carefully. Sure. How many of you say that if it's shifting first and flipping next, or flipping first and flipping first and shifting next, flipping first and shifting next? The otherwise, this is correct, right? So I'll come to that. I'll come to that. See, x of t. Say for example, we'll go with the first case. Okay, as you're saying, flipping first, right? Flipping first, x of minus t. Shifting next, but by what amount? Okay, it depends, right? So now see, if that would have been the case, it would have altered right shift, na? Right shift, that would have been x of This is different. So always remember, when this is the case, x of at plus b, the generalized procedure is first go for this shifting, or otherwise apart from this sign, okay, you always remember that this signs or the scaling factor is well distributed between these two. There is no part common. First shift, then scale. I'll come to that both ways. Okay, I'll come to that both ways. Okay, now the original signal was what? Okay, I'll draw that. This is the original signal. Huh? If you are not convinced, take values one by one, you'll be convinced. 1, 2, x of t. I want what? X of minus t plus 1. Forget about this. Forget about this thing. What is this? Towards right. By what amount? Towards left. By what amount? Shift the original signal by left by 1. What would the signal? Is it okay? This is what? X of t plus 1. But what do we want? X of minus t plus 1. That means what? This signal is reflected across the time axis. Time axis का level है, so it's like this. It's reflected across this axis. The axis reflected. So that means at the end, what we'll get is something like this. One minus 1, 0. This is what? X of no. Just because only the independent variable will get reflected. There is a catch. Okay, only operation display independent variable. That is just the constant. We are still not convinced to put various values in this variable. Right. The other way around. We'll go other way around. Okay. Now, if you would have given, you have now take the other way around. Okay, which you thought that that was correct. Okay. Take another signal and see those two signals will be different. Actual values calculate करके देखो ये value आ रहा है क्या? देखो. Put various values of take values. कौन से values लोगे यहाँ? हाँ, 1 डालो, हाँ, 1 डालो, बोलो. 1 डालो. Now you are convinced? Good. Okay. Those who are not still convinced, right? You are not getting that. हमने नहीं देखे जो सब समझ गया सब कुछ समझ गया आगे वाला प्रॉब्लम को आना चाहिए don't remember the things okay I'll take counter example if you are I think I'm seeing some blank faces I'll take some counter example so that you will be convinced No, it depends on okay. No, it won't come. No, take it. No, if it is -1, of course that will be. I mean, you are simply taking minus sign common, but that is not equivalent to if I take this. You are saying that if x of minus t minus 1, of course that will be, but that is not the case. They people have done right. I mean, they have treated this. Yes. So you avoid such confusions. Thumb rule, I'll simply state, whenever you find scaling and shifting operation together, this is what you should do. Got it? Now, the things will be clear when we take some more examples. Which one? Here? Okay. नॉट डिफाइंड नहीं है, ये वो जीरो है. हाँ, no, x of you are saying minus what? Minus what? 1/5, 1.5 ना, 1.5 is where. और करके देखो, इनफाइनाइट वैल्यूज डाल के देखो, समझ जाएगा. Isn't it? Now see, you should see that okay, जो चीजें वैसे दिखती है वैसे है नहीं, और इसके लिए बहुत प्रैक्टिस की जरूरत है. Isn't it? When you solve problems, then you will come to know. थंब रूल कैसा है, इतना इतना भी ये मतलब डिफिकल्ट नहीं है, रॉकेट साइंस नहीं है. देखो यहाँ, let's say we'll take this signal x of t. If it get scaled first and shifted next, it should appear like something like this. If it is shifted first and scaled next, it should appear something like this. Now it depends what values you take here. Now if we take same values, I mean a as -1 and b as +1, okay, if you put here, both signals won't be the same. What do we want here? What is the value here? You tell me here. What is the signal which we are having? A is, here you put the values as a is -1 and b is, this minus 1, right? Again it will become +1. So if we do that and put these values, the both these both signals won't be the same. Okay, so I'll write general case. When you need to deal with both scaling and shifting, first shift, then scale or replicate or reverse. This is what you should remember. Not remember, but you should understand. Some other signals will come to know. Okay, we'll deal with some more signals. Now, take same signal. Okay, I'm just same signal. You draw this signal. Okay, x of 3/2 t plus 1. Do that. Let me see. Draw the signal. जो इसको करेक्टली ड्रॉ करेगा उसको एक चौक. जो मैंने रट्टा मारा दिया आपसे, तो आप सही लेते हो, और इसको समझना चाहिए कि ऐसा क्यों. Now देखो अलग अलग वैल्यूज डाल के देखो अदरवाइज. फॉर एग्जांपल ये सिग्नल करेक्ट है नहीं, ऐसे कैसे चेक करोगे? अलग अलग वैल्यू डाल के देखो. ये ऑब्वियस थिंग है. ये देखो मतलब x of t से ये सिग्नल ऑब्टेन करना है, पहले मैं क्या करूंगा, तो this factor will be multiplied with only t if I put the scaling factor, if I do the scaling operation after the shifting operation. If I do it after, then this 3 by 2 will be, the scaling factor will be applied to both the shifting and the t also. What I'm saying is, see here, if this factor 3 by 2, I want it to get it applied to only t, okay, what should I do? I mean, scaling factor should be applied after the shifting operation. Otherwise, what would happen? This 3 by 2, if I do the scaling operation t first and then do the shifting operation, then it will be 3 by 2 t minus, that whatever the shift will be. The scaling factor will be applied to both. So the obvious thing is, if you want to apply the scaling factor to only independent variable, of course, first you should shift and then you should scale. Now you got, the way I was defining the blocks, the input signal. Except now these are the blocks, okay. First scale and then shift. That is the difference. If you shift first and then scale, then it will be applied to only t. If you scale first and then shift, it will be applied to the both. Okay, just because we need to apply the shifting operation to the independent variable, and hence the common factor will be there. I mean, the scaling factor will be applied to both the t and the shifting. Right? You got this? How many of you didn't get this? हमने कितने लोगों को समझ में नहीं आया है? देखो मैं अभी बोल रहा हूँ कि फंडामेंटल लेवल पे पूछ लेते जाओ. Yes, you didn't get. Okay, what I'm saying is, what if I scale this first? What will happen? Let's say 3 by 2t and then shift it by 1. What will happen? X of 3 by 2. Now t has been shifted, right? The scaling factor will be taken as common to both t and also the shifting factor. But what do we want? That the 3 by 2 factor should be applied to only the independent variable t. For that purpose, what we should know it is, should first shift. What will happen if we shift? This 3 by 2 won't come. T minus t naught will come. And then if you scale, it will be scaled only to this factor. Why not this? You tell me. Why not this? This is constant. T naught is constant. The scaling factor applies to only independent variable. What is that? What is the variable here? T, of course. So it will be 8. What do we want? We want case like this. That's why we want the scaling factor to be applied to only t. And hence that is the case. How many of you didn't get this? See, there is no problem in going otherwise. Okay, you can obtain the solution otherwise, but the shifting will be different. For example, what was that? 3 by 2 t plus 1. ये था ना? If I am taking 3 by 2 common. Now here, if we scale by a factor of 2 by 3 and then shift it, then it will be common. If we scale by a factor of 3 by 2 and shift it by a factor of what? 2 by 3, then it will be common. 2 by 3, right? Because 3 by 2 is common otherwise. You try this. ये ऐसा करो. ये जो सिग्नल है, इसको ड्रॉ करोगे. ड्रॉ करो इसको. X of, you'll get the same signal. What I'm saying is, first, now, okay, forget about that. You just do this thing. Okay, x of t पता है आपको? X of t पता है? उसको पहले पहले अपन ने क्या किया था? पहले शिफ्ट करके स्केल किया था. अभी स्केल करो 3 by 2 से. पहले स्केल करो. First scale the signal by 3 by 2 and then shift by 2 by 3. Do that. Okay, I will note down the things. What I am saying is, okay, इसका अर्थ मैं यहाँ पे लिख देता हूँ. In order to obtain 3/2t plus 1, यही था ना? हाँ. You may either shift left by 1 and second scale by factor 3/2. That means divide the x-axis by 3/2. मतलब वो 2/3 आएगा, उल्टा आएगा. Or this is equivalent to x of first scale by what factor? Yes, of, then shift by what factor? Yes, very good. मैं बोल रहा हूँ कि ये दो चीजें इक्विवेलेंट है. ओके, तो नहीं सर ये सब कंफ्यूज हो रहा है, पहले स्केल शिफ्ट ये वो. कम रूल हमेशा याद रखो. इफ यू आर गेटिंग सच इक्वेशन at plus b, ऑलवेज रिमेंबर फर्स्ट सिंप्लिसिटी के लिए मैं बोल रहा हूं पहले शिफ्ट कर लो. विल प्रीफर दिस, फर्स्ट शिफ्ट एंड देन scale or flip. Is that okay? Shift by what amount? That should be very clear. Shift by what amount? B. Scale by what amount? A. Scale by A means what? Divide x-axis by. अब ये किताब में नहीं मिलेगा, ठीक है, मतलब अंडरस्टैंडिंग है. किन लोगों को ये समझा? नहीं समझा? होमवर्क. Take this example. देखो आप अगर प्रॉब्लम सॉल्व करोगे तो ये डिफिकल्टी नहीं रहेगी. Consider the signal x of draw the signals. Okay, x of t minus 1, हाँ तो इसलिए मैं नहीं लिख रहा हूं. अच्छा वो हाँ 1 2 ठीक है. सिंपल सिग्नल. जिन लोगों को ये बिना देखे बिना किसी के साथ डिस्कस करके सोच समझ के खुद से अगर किया तो उसको सब आ गया. ठीक है, ट्राई करो एंड देन वेरीफाई. जितना क्लास में बताया है उसके बेसिस पे आप ये सॉल्व कर सकते हो. ठीक है, वेरी सिंपल. इफ यू गेट करेक्ट आंसर्स, ओके, you are very you know this concept well. Okay, let's stop here.